So despite the fact that this machine was made in Austria, I wouldn't have assumed that Arnold Schwarzenegger himself was the one assembling these plugs. Holy crap. Each of these screws, sheesh, they're like so tight. You really gotta crank into them to get them to break free. But I'm getting somewhere, making a little bit of progress. I've got so these are 24 volt going out to limit switches into inputs 5 and 6. 1, 2, 3, and 4 on the input side of each Mesa card is available to utilize analog input. So 1, 2, 3, and 4 I usually leave out of my input chain so I can use potentiometers for my jog, feed override, and spindle override. So that's what I'm going to do on this machine. I found a project box that has an angled front with a little metal plate that you can use to mount all of your hardware to. So that'll be here tomorrow, which should be cool. I'm going to build a little control center out of that. I've got some push buttons that I ordered. I got the jog wheels in. I don't know if I have one down here. Did I bring the one down here? I don't think I brought the one down here. I've got 2 of the silver ones I bought. It's funny, I made mention of the $8 jog wheels, and by the time I posted a link for somebody that was asking about them, they jacked the price up to $24. So I got lucky on those. I only paid $8 or $8.50 a piece for 2 of the jog wheels. So I'm going to have 1 jog wheel, toggle switch to select X and Z axis, and yeah, like I said, I'm going to have probably cycle start, feed hold, single block, possibly mode selection, so jog mode, auto mode, MDI mode, and then if I have enough room, maybe I'll do jog buttons that will tie into the feed override knob, and then I'll have an override knob that I can use to to control my jog speed and my program speed, program feed rate. More than likely, I can use an exclusive OR statement to select between the jog and the feed override with the 1 knob. So that would eliminate having to use 2 knobs. I know on some machines that I work on, some machines will have the same knob, and other machines have separate knobs. So it all depends on how I can get that to work. So I found this angled project box on Amazon. It's got a nice slope to it. Plenty of room, if I can get it open here. Plenty of room, nice and deep. Got my MPGs. So MPG is going to go here. Got some push buttons that I'm going to use. I'll have my MPG. Here I'll do my cycle start, feed hold, and single block. Here I can have my additional controls. I'll have axis selection, resolution selection, and then I could do rapid override, feed override, maybe some jog buttons here if I have the room for it. Maybe I'll get some of those little teeny tiny ones that I can use. So that's going to, that'll mount to the front or the right side of the machine. To be determined, because I've got this stupid table vise in my way. So either mount it to the front here, where it doesn't get in the way when you're leaning over, so you can come up to the machine, work on it, and you'd have your controls over here. Or mount it directly underneath this guy here to the side, put a little bracket underneath to support it, and then you've got your hand wheel here, and then you've got access to emergency stop. I'll spare you the details of how I got to where I'm at, but suffice to say, I got the board powered up. Not only do I have the board powered up, but I've got the drive board ready, but it's not in an enabled state yet. I'm trying to trace back where I have to connect an enable signal. I was told that there might be one on the ribbon header, either I think pin 16 or 15, one of them. I have to see what kind of voltage goes into that, but otherwise I got my motors wired up, step direction going into the board. Not sure if it's right yet, but if it runs backwards I can just flip something around. Got the 24 volt power coming in from the transformer, going into the field IO here. Limit switches are working already. One of them appears to be wired for normally open, and one of them is wired for normally closed. So I had to invert one of the pins, but that's just a matter of fixing a connection on the limit switch side if I want them both normally closed. So today is tomorrow. Yesterday was just a figment of our imagination. So I was talking to a guy that interfaced one of these. Actually, he did a PC Turn 50, and this is a 55. The difference being that the 50 did not have the VFD. This one's got the VFD that goes up to 4,000 RPM with the spindle encoder for threading. That one just had an Emco built motor drive and not a variable frequency. So I was talking to him, and he said, when you power this machine up, it has to have, this board has to power up in a not so happy state. Because last night I was bashing my head out going, all right, I got green lights, why am I not moving? So the board has to power up in a state where you've got the two red LEDs in the middle, and then you connect the 5 volt to an enable signal, and it'll activate the drives to make sure that everything can run. So that being said, you can see I've already done some, but it's moving. I'll put it in continuous. I got it up to 75. Well, I don't know if the motors are tuned properly. I'm just using some numbers that I found, but the thing cooks, man. It moves. So I'm happy about that. Next project is getting the VFD hooked up. I have to trace out some of these wires still. I can't get the contactors to come on, so that's why I've got the spaghetti incident going on here. I can't get these contactors to trip on. So there's 24 volts that's got to go to these to power the VFD. I did toggle the manual overrides yesterday, and the VFD did kick on, so I know that there's life in that thing. I just have to trace out, because I'm positive that terminal 10 on this gang block here is supplying 24 volts to these contactors, but I'm not getting it. So I got to figure out which, if any of these, is a jumper that was originally plugged into the AC95 board to jump the connection when it was in enable state to tell the contactors that it's ready for full chooch. So that being said, stay tuned for more. So as messy as this looks from the outside world is as clean as it's starting to look to me. What I'm doing is I'm pulling out every single strand of wire inside of this ductwork, and just trying to pick through each thing, clean it up, sort it out a little bit better, maybe trim some of the extra that they left in here. They left about a foot of every wire you could think of inside of here, which really clutters up the duct space. If you weren't planning on ever pulling it apart again, or if I weren't planning on ever pulling it apart again, I would just stuff everything in and keep staring at the electrical diagrams. But you really have to trace out the safety circuit on this thing, and I figured, what the hell, I'm better at looking at wires than I am looking at schematics. So yanked everything out, and I did discover that this one wire, this guy here, runs through all of these pigtails. So there's what, 1, 2, 3, 4, there's 6 pigtails connected to one wire. You can't see that in a book, or at least not without staring into space for an ungodly amount of time. So I got all my ground separated. Those are easy. Those are just, ground. Just hook them up to the bus bar. No big deal. For anybody who's ever interfaced these before and they didn't really quite know what this guy was for, this is a 30 volt input off of the 30 volt supply on the transformer. And I can see that clear as day now. There's no blue wire in my way. So hopefully, between tonight and tomorrow, we will have a lot of these contactors going with some VFD action. So I seem to be making a little bit of headway and getting rid of a lot of excess wire. So, oh, there's another one, see? Just wire everywhere. So what I'm doing is I've been going through and I've been studying these terminal blocks. Now, these are common connection terminal blocks. So each of the numbered sections provides a connection for 1, 2, 3, 4 wires to connect to this same terminal block. These are quick release style. So what you do is you take a screwdriver, put it into the slot. It's not the right one. I'll get the other one. Take a screwdriver that fits squarely into this little guy here. Push down and then rotate this way. So you got to kind of catch it and push. And what that'll do is it'll release a spring inside of here. This one will, this one here will do this one. This one here will do this one. And this one here will do that one. And it'll release it so you could put your wire ferrule in. And once that's in, you release your screwdriver and it bites in. The holes in between, these are test points. So you can take your multimeter test probe, stick it into the old hole-a-roo here, like so. And it actually fits. It's got a nice little friction fit so that once it's in place, it'll stay there. So it's good for walking around to the front of the machine and troubleshooting what you are looking to do. So right now I'm just trying to trace out my door switch and my side panel switch, because there's a safety side panel here. Not that I'm going to need this stuff, but so safety side panel switch here. And on the front, there's a switch here. And both of them will break contact to the machine or to the electronicals whenever it senses a door open on either of those. Plus there's the emergency stop. So what I'm thinking of doing is actually tying the door switches into not so much an emergency stop, but maybe a single block condition or something like that. So when I open the door, it'll feed hold the machine and allow me to kind of peek my head in. When am I ever going to have to peek my head in on a machine that's, you know, this small? So I don't know. It's kind of, it might even just be a moot point. Just, you know, put a warning label on here. Don't mess with me, or, you know, you can die and it'll hurt the entire time. So just trying to fish out what's going on with these contactors. I've already had to pull out one of these guys because it went to the X111 plug, which is now in the can. Nice thing about it is that it gives me a little bit of extra, you know, well identifying blue wire to pinpoint things with the next time I want to connect something. So for the time being, I'll get these all traced out. I'll find out what is important, what is not important, what's just jumping around to what, and see if I can mainline it a little bit better. But I have got the contactors mainlined into this this set of terminals here. This yellow thing is a jumper that actually shares the connection. I got a marked 24 volt and 0 volt common. 0 volt common on this machine actually ties not only to common on the transformer, but also common as an earth ground. But I've got them tied into position number 2 here, which is also shared between these guys, but they don't interfere with one another. This is just providing 24 volt out to all of the devices attached to this section of terminal block here. And then this terminal block here is just providing the common return for those. And then these are the individual switches that go out from one to the next, to the next, to the next. So I got these attached to the inside, the positive side of these contactors. So when I make pay dirt and plug it in, contactors kick on, VFD kicks on, gives me the little ready state green light. So that's a good sign. It just means it's got life. Now I have to take a chance and plug in my analog spindle controller and see if we can see some puffs of magic smoke. Alright, so today is a couple of days later than the last video. I was very successful getting the VFD to run. The wiring didn't quite fall in the way that I thought it would, but eBay Claus was here this morning and left me a nice little toy, new power switch. I got that on eBay for $10, and it came with this contact here, and the rest of them just dropped in right from the old switch. I got a new one because I didn't have the key. But now I have a power switch like a normal person. As far as the VFD is concerned, so the way that I have it hooked up right now, it's a little Frankenstein-y, but the way that it is hooked up at this panel here, the original wiring had the white wire in the 62 position, which in the nomenclature that they give you says that it is an analog output. And I'm thinking that this was an analog voltage output, but what it is it's actually an analog voltage output. It's a variable analog voltage output for some sort of meter. So if you have a meter feedback for your RPM, you can tie it to that lug there. So I don't know what it was feeding back into. It may have been feeding back into the original computer to let it know what the speed was, but it doesn't make any sense because on LinuxCNC, I'm going to be using the encoder to tell me what the RPM is. The brown wire is ground. There's actually 2 ground points on this panel here. 7 and 7 are ground points for either, you know, for they're both the same. They're shared. So either one is a ground point. The green is your speed in. So this is what tells the VFD how fast you want to go. So I'll show you the pinout on the 7i7-6. It's here. So the way that it's set up is the ground is here. The green is the variable output. The white is the voltage in. So this lug here, or this terminal block here, will accept a 10-volt analog input and then send out the variable input based on the speed you have set in LinuxCNC. So spot number 9 here, this is the analog potentiometer output. On a lot of other VFDs, it's going to be 10 volt. This one outputs 5.2 regulated. And again, the 7 is ground. 20 is a voltage output for powering the I/O section. I'm kind of kneeling down. It's kind of tricky to hold myself up here. 20 is a variable, or is a set voltage output of 20 volts. 28 is the enable signal. E1, 2, 3, and 4 are basically like miscellaneous accessories. Like there's a jog speed one you can set up, and in my case, E4 is the direction pin. 39 is the I/O common. 59 is a 24-volt input, and then the A1 is a 24-volt output to an enable signal. And the way I have it set up right now is I've got 24-volt and the red common coming out of the field I/O block here. And then I've got, let's see if I can move this stuff out of the way here. I've got a 24-volt gray return wire coming into the terminal number 8. And then I've got the blue wire in terminal 7. I've got a jumper from 8 to 6, which ties into the enable. So this is the direction pin. This is the enable pin. And then again, I've got the potentiometer stuff at the bottom. I think I'm going to switch this a little bit and run number 20, which is the 20 volt into, focus, the 20 volt into here. And then I have the gray accessory, or the gray enable wire. Really, it's like a, it's like an enable signal, really, that'll spit out. I could put it into an input, and then if the VFD loses power, I could set up logic to stop the machine with that pin right there. So that's what I've got going on. It was a little different than I thought it would be, but it does work. I had to move the, where is it? I had to move the dip switch on the VFD unit. It was set up for 10 volt, and I've only got a 5 volt potentiometer. If I had 10 volt going into this, I would have to flip dip switch number 5 back up. That was really the only difference there. It runs strong. So I'm gonna, I'll fire it up and I'll take a video of it running. But right now, I'm moving on to, well, cleaning up a little bit of the wiring, and then I'm going to get into putting the turret board back in. I only took it out just for safety's sake so it didn't get knocked around. Put the turret board back in, run my 5 volt to it, 24 volt to it, and see how she goes.